Tēnā koutou katoa. I te mana whenua tēnā koutou. Ko tararo te maanga, ko rangatāne te iwi, no tautuku au. Ko Jesse taku ingoa I akuna au I te whare wānanga o Waitaha. No rewa, tēnā koutou katoa. Kia ora, my name is Jesse Scott from Student Engineered Solutions. As per our brief, we were tasked to compile the concept design report for stages 4 and 5 of the Redmond Spur development. Our brief required our proposed design to have 60% residential land, 20% commercial, 20% recreational, and options for a proposed cycleway connection. We were also required to focus on minimising the environmental impacts of our proposed design, with a particular focus on transportation and roading, the free waters, and geotechnical issues. In our proposed design, the residential land was primarily situated on the northern side of the development. This would be the most desirable area as it is north facing. We have the highest sunshine hours. The proposed 42 residential lots have a large variation in size to give multiple pricing options for potential owners. Extensions to the already zoned commercial land at the top of the subdivision were made, and a section of the southern end of the site was also designed to be a commercial area to make up the remaining 20%. The bottom section was designed to be a commercial hub of the subdivision, to provide convenience to residents by placing all shops they may need on a regular basis in one location. The gully and the wooded section at the top of the development will be our proposed recreational land. The road layout was designed to minimise the overall excavation required. This was the driving factor in our design and the reason why it was chosen as our suggested layout. The alternative layout was designed to minimise the shading on the gully and also give a larger flexibility on lot sizes in the stage 4. However, this was only suggested as an alternative as it required extensive earthworks to meet the Christchurch City Council grade specifications in comparison with other designs. The proposed cycleway connection was designed to merge seamlessly with the already constructed road in the lower stages. The carriageway is designed to have adequate width to maintain traffic in both directions, as well as parking, a single footpath and a planted berm. The utilities were also placed to provide an easy transition into the lower stages. An alternative design added the addition of stormwater soakage to the previous. This was only suggested as an alternative as the soil located on site has a potential risk of erosion if not properly maintained.
Tēnā koutou katoa. E te mana whenua tēnā koutou. Ko Zijing te manga, ko Long River te awa, ko Jiangsu Province o, ko Liu taka ingoa. He akonga o te I whare, wānanga o Waitaha. No reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. Hello, my name is Ruiming Liu. I am going to talk about our cycle connection and a bus service design. Due to the hilly terrain inside the development, a 2-meter wide footpath will be shared between pedestrians and cyclists instead of a special design cycling. While out of the development, a separate cycleway is recommended to be added along Kashmir Road all the way to Quarryman's Trail on Horswell Road. This route was chosen because it has a shorter commuting distance, hence lower construction cost compared with the alternative design. For public transportation, it is recommended to extend Line 100, which originally turns around in Horswell to provide a bus service to our development. Line 100 was chosen because it has a higher frequency and easier routing management compared with the alternative Line 145. It is recommended to have one bus stop positioned at the Kashmir Road, whereas near the bottom of the subdivision, and the other near the top of the loop. The current road layout must be upgraded to create a safer cycling environment. Approaches such as road widening, lowering speed limits are recommended for the roads. The upgraded roads should provide enough space for buses and cyclists to commute at the same time. A separate cycle lane is much preferred over other designs in this case.
Tēnā koutou katoa. E te mana whenua, tēnā koutou. Ko Taranaki te maunga, ko Kaupaka Nui te awa, no Kāpanga au, ko Mason taku ingoa. He akonga o e te whare, wainanga u Waitaha. No reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. Hi, my name is Mason Blowman, and I am the Water Supply Designer for Student Engineered Solutions Limited. The first part of this design involved investigating the existing infrastructure so that we could determine what extensions were necessary for the design. This was done through a desktop study that involved considering some of the key design considerations such as those listed on the slides. For example, the peak demand flow was needed to ensure that all households have sufficient water supply all year round. The peak flows change from month to month as well as on a daily basis, as you can see on the graph. The graph shows that the summer demand in blue and the winter demand in red have significant differences from one another, and this can have great effects on the water supply. This was accounted for in the design. Other things such as fire services, pressure head, and the design life of the system were also important, as these can affect the quality and serviceability of the supply. It was found through evidence of Bridget O'Brien on behalf of the Christchurch City Council that a new reservoir would be required to supply all allotments up to a yield of 400 lots. This includes stages 4 and 5, as well as further development. The evidence also implied that the new reservoir would need to be built above the 210 metre contour line. This is so the pressure head in the system can supply the lower reaches of the subdivision. The area I've suggested for the location of the reservoir can be seen on the slide and is located on the Kennedy's Bush track. The size of the reservoir was estimated based off the average peak flow. This accounted for the required fire services and other design standards. It will also allow for up to 48 hours of storage. A number of pipe sizes were selected based off the existing pipe network in the earlier stages of Redmond Spur. The material was also selected as PE100 due to the design requirements and cost benefits associated with it. These selections were checked against the design requirements discussed in the IDS as well as the New Zealand Standard 4404. However, these will require further checks that will be necessary in the detailed design to ensure that they are adequate. Throughout the detailed design phase, we will be required to obtain the necessary resource consents such as land use, water discharge and water permits. These can be obtained from Environment Canterbury and through the Christchurch City Council. This also involves consultation with the affected raunanga before applying for the consent. This is especially important for the new reservoir, as the suggested location is also known as Otumatua, which is described as a sacred place by Te Raunanga o Ngā Tahu. This would require further consultation with Mahunui Kurutaiao before obtaining land use consents.
Tēnā koutou katoa. E te mana whenua tēnā koutou. Ko koko te monga, ko raukawa te moana, no poneke o, ko Florence Marshall taku ingoa. He akonga o I te whare wananga o Waitaha. No reira, tēnā koutou, tēnā koutou, tēnā koutou katoa. The main issue affecting the choice of wastewater management system for the Redmond Spur subdivision is that the current Christchurch City Council infrastructure is already nearing capacity. A system needs to be installed that can cope with any future development as well as fit in to the existing system. The two options that were considered were a conventional gravity-fed method as well as a pressure sewer system. The natural gradient of the land could mean that a gravity network could work well. However, these pipes are larger and need to be dug deeper as well as being less robust than those of a pressure sewer system. This results in a more difficult to install system and it being more expensive. A pressure sewer system is often used when there are downstream capacity issues, as is the case for Redmond Spur. Therefore, it is recommended that a pressure sewer system is used in this situation. This system works by installing a small grinder pump on each property, which then pumps wastewater into the shared pressurised main. E1 pumps are the most common pumps used in the Christchurch region. The ability to discharge wastewater at off-peak times into an existing system is important. Peak smoothing results in the peak flow only being twice the average flow as opposed to 5 times the average flow for a conventional gravity-fed system. After heavy rain, when the flow is at a maximum, wastewater can be stored in the 24-hour emergency storage tank and then discharged at non-peak times. These capabilities are advantageous as the wastewater flows can be discharged into the heavily utilised system at non-peak times. Section 6.9 of the Christchurch City Council Infrastructure Design Guide should be used when designing precious sewer systems, and a building consent is needed for connecting the new system into the existing Christchurch City Council wastewater network.
E te mana whenua tēnā koutou, ko taranaki te monga, ko waimea te awa, ko ati awa te iwi, ko kona taku ingoa. He akonga au te whare waianga o Waitaha. Nō reina, tēnā koutou, tēnā koutou, tēnā koutou katoa. Hi, I'm Connor, and I was the stormwater engineer representing Student Engineer Solutions on the Redmond Spur project. Stormwater control will be a significant aspect of the development of the subdivision, as it is heavily connected to the ecology of the surrounding hills. Therefore, it was important that an environmentally friendly solution was put in place. The geography of the subdivision poses some difficult challenges for stormwater, as the steep slopes increase runoff speeds, which is an issue since the surrounding lossless topsoil is prone to erosion. Several consents from Environment Canterbury will be needed, including discharges to land and surface water bodies, as well as works within a riverbed. To collect the stormwater, a pipe network under the road will connect roof downpipes and roadside drains and guide all the water into an open channel that will run down the centre of the gully. This channel will be lined with riprap and heavily vegetated along its banks, allowing it to blend in as a natural feature over time. To make the most of the water available, residents will be encouraged to install rainwater collection tanks on their properties, which will then overflow into the stormwater network. The lack of flat land and soil strata at the subdivision make on-site soakage an impractical method for stormwater treatment. Weighing up the options, it is instead recommended that a separated first flush and dry detention basin be used to store and treat the stormwater before discharging it to the Christchurch City Council Sutherland Stormwater Facility across the road from the site. The benefit of a dry detention basin is that it can double as a recreational area when it is not being used in a flood scenario. The Port Hills have unique geotechnical issues, as the fine lossless soil is prone to surface and tunnel erosion. There is already tunnel erosion present on the southern side of the site. Because of this, care must be taken during and after construction to limit water infiltration. During construction, PVC coverings will be used on subsurface earthworks to reduce infiltration. Along with this, vegetative planting such as grass will be encouraged whenever possible to stabilise the soil after earthworks have taken place. To achieve the required road layout, a retaining wall will be required at the top section of the site. To promote stability, engineering fill will be used behind the retaining wall and in any other areas where fill is required.
The table shows a summary of total construction costs for each section of work. The total cost estimates come to 11.7 million inclusive of GST. The actual cost of the project may change when a more detailed design is completed. Hence, a contingency of 20% has been included within this total estimate. Based on the sales situation of previous stages, the designed two stages are hopefully to provide a total revenue of 15.5 million, which would yield a total profit of 3.8 million. As the estimates for costs and sales are both very conservative, an ideal profit margin is guaranteed. Combined with the long time frame of the project, the financial feasibility of the development of stage 4 and 5 is high. And that wraps up our presentation. Thank you for watching.